Welcome to the first part of the Lidar tutorial series. Today we're going to be covering the basis, so that means making a transparent world and shooting out points. In the next part we'll cover things like color and how many points and different things like that. So currently I'm going to start a blank project and I'm using Unreal Engine 5.4. And what we're going to do, I'm going to use the first person, but it works just as well with the third or the top down or any other one because it's very basic. We're just going to add pretty much some line traces. So it can work with any of these. But we're going to pick the first person. We're going to put blueprint and we'll just call it Lidar Scanner is what we'll call it for the project. So I'll see you guys once it's loaded. With that, we have our project loaded. So the first thing we're going to go and do is we're going to set up an input for our Lidar. So we'll make a new folder, that way it's all sorted in the same spot. So new folder, and we'll call this Lidar simply. So let's add an input by making a new folder for our inputs. We're going to start by adding a normal input, so we're going to go for input action. So IA we'll call scan. That's what we used for. It's simply going to be left click. Yep, there. So we don't need to change anything here. Make sure everything is pretty much by default. Normally it should look like this. And we are going to right click on it and we're going to say create an input mapping context. And so it's going to be IMC scanner. And we already have our input right here. We just need to change its key. So click on the keyboard and we'll use left click. So left mouse button. We can close it up. We don't need it anymore. The next step is we need to make sure that it appears in our first person character because that's the one that's appearing here. If you chose a third person template, then it's the third person. So we just want to open it up. Okay, so within our event graph here, for our first person character, we're going to need to add the event begin play. And what we're going to do is we're going to get our player controller so that we can add a new mapping context. So we're going to get input mapping, no, sorry, that's not right. Enhanced input local player subsystem. We're going to check if it's valid. So it's valid. It's just a precaution. Usually it should be, but just in case we keep it like this. And we're going to say add mapping context from our enhanced input local system. So the context we're going to select is our scanner. And just to check if everything is working, we can just add our IA scan here. And what we want to use is triggered. So we're going to put a print here just to see that it gets called once we trigger. So right here, if we just play, we're on the right level. We don't need that, but if we print, yeah, it does print if we hold left click. So that's working just fine. So most of the work is going to be just here. We're going to collapse this by right clicking collapse to function, and we're going to create a new function that will serve as our scanner. So we're going to call it scan area. So what we're going to do in here is we're going to have a line trace. To get the line trace to function correctly, we need to have multiple points every time we scan. So for that, to get that result, we're going to add a for loop here. So that way, instead of just scanning once every click or every triggered, we can scan X amount of time. So we're going to put 7 here for now. And then what we're going to do is we're going to call line trace by channel. And we'll make a function here for the start and the end, so that way it is easier to organize. So just drag 2 points out here, hold R when you're dragging to make a reroute node, select both of them, right click and collapse to function so that they get considered as the output pins. And we'll call this make start and end. We can convert this to a pure, there we go, and we'll just change the output pin names to start and end, that way it is clear. So we can get rid of these for now. We'll keep the return node on the side, just move this to the beginning. Okay, so what we need to do first to get this to work, we need to know how far we're going to shoot. So in our case, we'll make a variable for this, and this is also part of the kind of customization later, but we need this, might as well put it now. So this is going to be scanner range. Right here, it's going to be a float. And by default, we can put it something like 7,000 so that it has a decent range. We want to make sure that it's not 0, or it's useless. And we're also going to need another float, which we're going to call scanner angle. And this is going to be used to determine how far out it will look. And so what we need to know here is we need to know how far out the scanner is going to be if we take an initial point and we're going to kind of draw a triangle, and we're going to say how far at the edge, so at our scanner range, can the point go out. And so to get that, we're going to use the sinus here. So we're going to do sine in degrees, plug it in here and multiply it by the range. And this will give us the actual range of the end point. So we'll promote this to a local variable here, which we'll call x and y range. Now, the next step, what we need to do is we need to know how we're going to randomize on the x and the y. Because now we have the maximum value they can be. We now need to determine if they're going to be 1 on the x or -1, or what they're going to be on the y as well. And that will randomize the angle we have in our kind of grid, you could say. So to do that, we're going to use two different local variables again. We'll call random x, and we'll duplicate again and call it random y. So both of these will be right here. Connect them both up. And we'll just make a random float in range, because we want to make sure that we can have between -1 and 1. That way we don't have to do a negative value here. We just simply have these determine the kind of alpha we'll use here. Next, just to make things more readable, we're going to get a new, or two new local variables. We'll call end or start point, and we'll duplicate for end point. And these are obviously going to be vectors because they're for the output. So we're going to start with the start point. So just connect this up, and we're going to need a bit of space, so just give it a bit of space here. So the first thing we need is we're going to add multiple points. So the first point we want is we need to know where the player character's camera is, because that's where we're going to start scanning. So we'll say world location get, and that will be our first point. That way we start in the middle of the camera. Now, for the start point, you could just do the middle of the camera, but we also want to give it the same offset we have at the end as we have at the beginning. That way we have kind of, if we're close to something, it won't just all block in the middle. It will kind of have a bit of offset if needed. So to get that result, we need two more points here. We need to take into account the x, and we need to take into account the y. So what we're going to do to start is we need to take our random x, so right here, our random y, and we're going to multiply them by the camera's right and the camera's up. So for x, we'll use the camera right. Sorry, not camera, but get right vector. We will multiply this here, but we also need to add a second value here, and that's because this is just an alpha, so 0 to 1, or in our case -1 to 1, we need to give it a size, and that size in our case is going to be just 10. And this is kind of just fixed. It doesn't really matter what it is, but 10 is just something big enough. And so we can just duplicate this, and we're going to do the same thing here. We just need to replace the right vector by the up vector, and we need to replace x by our y by right clicking and changing it. There we go. So now we have our two different extra points. So this will add an offset now. It'll be a bit different than what it was before now. It will start slightly off and a randomized position. Now, we're going to use these same things right here. So I'm just going to copy them for the end, but we're going to need an extra piece, obviously, because now we also need to add the distance. So for the distance, it's pretty simple. We want to get the first person camera again. We want to multiply this time, instead of the up or the right, we want to get the forward. And so the forward, we are going to multiply it by the range, which we already have here. Scanner range, plug this in here. So this is a global variable. Let's just line all this up tightly. There we go. So we're going to plug these in back in because we did already have them. And we are then going to take our endpoint, hold Alt to put it as a set, and plug the endpoint in. Then we can return the start and the end. So just like this. There we go. So we can compile, and now we have our start and end. I'm just going to double check we have everything right. No, we do have an issue here. We don't want to have 10 here because now we're at the end. At the end, we want to use our X and Y range. So plug this in here. There we go. So we can compile, and we can close this now. So just to test this out, we're going to debug for only 1 frame. Or actually, no, we'll do duration, and we'll just pause to see if it's working. So if we click, and let's just, F8, sorry. So we do have some random points. They're not just going straight in one area, they're spreading out, they have a decent range, and they're hitting walls as they should. So the next step we have to do here is we need to take that information where we hit and place something there. So what we're going to use to place, initially I tried this with particles, I tried it also with a kind of whiteboard system with the render targets, but that turned out to be a bit annoying because of how scaling works with textures and how if the UVs aren't perfect it will duplicate it, so it wasn't really great. So I ended up just going for the simple approach, which is instant static meshes. So we're going to get into that right now. The first thing we need to do here, and this is a bit kind of may seem strange, is we're going to need to store our instant static mesh inside of another actor. So what we want to do is we want to say get actor of class, and we want to have it singular, so make sure it's a single class so you have a single output here. And we're just going to look for a static mesh actor. And we're going to take the first one that we find, promote it to a variable. Well, actually, we don't actually need to promote it because we can use it elsewhere. We're just going to use it directly here anyway. So with this, we want to say add instance static mesh component. So this one right here. And what this will do is it will create an instance static mesh on that node. And we're just going to save this here and add instances to it as we go. So we're going to create a variable for that, so promote variable, and this will be ISM reference, we'll call it. There we go. Now we just need to set up our instance static mesh by selecting it. I'm just going to make sure we do that correctly. What static mesh we're going to be using? We're going to be using a plane, and the plane we're looking for is, I believe, the plane that is in the engine basic shapes folder. So it's on the other screen for me, so I'm sorry I can't show that, but normally if I hover here you can see the path to it. So it's engine basic shapes plane. That's what you're looking for. So now we can compile, and we're gonna have to make a material for this, but we'll get to that in a second. We can disable gravity, we don't need that. We don't need any collision at all, so no collision. The character's not going to step on it. We don't need to generate any events. And I believe that is enough. Also, yeah, we don't want to cast shadows because it's going to be kind of a light source of sorts. So compile. And for now we have nothing, right? So we're just going to make a texture for this first. So go ahead, back in our Lidar, we're going to make material. And in the material, we're going to make a material which we'll call plane, or we'll call it point. So go ahead and open that up. And it's going to be rather simple. There's not actually that much we need to do in here, I believe. There's only one key thing I want to make sure you do, because if you don't do this, it's not going to work. And usually some people do have issues with this. It's when working with a material, if your material is set to work on a decal, a particle, an instant static mesh, anything that's kind of not a basic skeletal or static mesh, you need to make sure that you go down in here in the usage part and find what you're trying to use it on. In our case, we're using it on instant static meshes. So we need to make sure that we check that so that it knows that it's going to be applied to that type of actor. The next thing is pretty simple. We want to have a color. For now, we're just going to store a color, even though we won't be changing it. So color. And we'll leave this white by default. There we go. And this is going to be plugged into our base color. It's also going to be plugged into our emissive. And right here we have our point pretty much. But there's one extra thing we need to add, because currently what we could do here is we can make it two-sided. That way we see it on the other side. But there's another trick that can help, which will give it a kind of sprite-like function. So to do that, we want to get our world position offset here and look for sprite. And we're going to select this one right here. And the only thing we need to change is this, so our 2D scale. And what we want to do is we're going to make another vector parameter here, and we'll just rename it to size. By default, open it up, and we want to put 1.8 on the RNG, because that's pretty much the X and Y values. And we're going to plug those into here, but to make sure that it works, we're just going to make sure we put a component mask of RNG. That way it passes a 2D vector without us having to bother to have two different scalar parameters. So now, it may not be perfectly visible, it's actually just gotten very small, but this is the appropriate size we're going to need in world once we get to that. So now we have a very tiny point, but it turns with the camera no matter what. So if we're below it, on the side of it, it will always look the same. So we want to apply this, go back to our first person character, and we're simply going to change our instant static mesh to our new material. So normally if you still have it selected, you can click on the arrow here, and we now have our point. So the last thing to do is to have it appear if we hit this right here. So we're going to break our hit here. There we go. And what we're going to do is we are going to take this right here. So what we're going to do here is we're going to get our ISM reference and we're going to say add instance. Just like that. And the instance we are going to add, we need to put its transform. We're going to split and we're going to put it in world space. That way it's a lot easier to do. And all we have to do here is we want to take our impact point, plug it into here, and that'll do the trick. Because we don't need to touch transform because we have our sprite system that will handle that for us. So it's not necessary. So then we can close that, compile and save. And normally, if everything worked well, if now we shoot, like that, we should have points appearing. So we're going to have to wait for these to disappear because I forgot to remove them. But we do indeed have points appearing. So let's just redo it again without the visibility, just to try. And also not sure, but yeah, I think I made a mistake there. The current angle is 7,000, which is a bit too high. So we're going to actually reduce that a lot. It needs to be something more like 14, because we're talking in degrees, so we don't want it to be too wide. So now if we try that again, there we go. We have our grid appearing like this. And so obviously right now it doesn't look like much because you can still see the whole environment around you. Once we start actually darkening the world around us, then we'll actually get a nice effect. Now, one thing to note is that it doesn't care about moving objects. And the reason for that is because, well, it's an instant static mesh. We can't attach individual ones to the actual thing they collided with, sadly. So we have to deal with this. So the next thing we need to do is we need to make sure that they disappear, because right now they stay there and they never disappear. So we want to add a kind of cooldown to them, so to speak. So for that, what we can do is we can make a variable for that, which we will call scan duration. And it's going to be a float, and by default 8 seconds is correct, or you're free to do whatever you want, but 8 seconds is usually okay. Now, one other thing we can do here is we can turn this into a variable as well. So we're going to promote this, and this is going to be points per frame, we'll call it. So by default, because we got it from last index, it will keep 7. So right here, just line it all up again. So the next thing we need to do is we actually need to save, or how to put it, no, we need to remember which points we placed when. So that way, every 8 seconds after they're placed, we can remove them. So to do that, we're going to use a timer. So on completed here, what we're going to do is we're going to say set timer by handle, or by event, sorry. Set timer by event. And we're going to have to create that event. So that event is going to be timer complete, we're going to call it. And we'll just leave it empty for a second. We're going to get to it right after we finish with this. So we're going to say create event here. And then we just want to reference our timer complete. Now, to get this to work, we need to plug in our scan duration right here. And we also need to convert this, or save, sorry, the return value to a parameter. So promote to a variable, and it's going to be, we'll call it Lidar timer, or scan timer. And just because of how this works, because you can have a timer active while this is happening, we need a branch to check whether the timer is already active. So get a reference to it, drag out and say is valid timer handle. If it is, we need to do the actual event directly. So we're going to call our timer complete directly. Otherwise, we're just going to call the timer to happen, or the event to happen, after the time is gone over. So timer complete is what we do now. Okay, so I just made a mistake. We actually need to do something else first before this. And that is we need to actually inform it. We need to save the actual points that are being added. So how we're going to do that is very similar to what we have here. So I'm going to copy this and actually collapse it to a function as well. So collapse the function is going to be called add points. We're going to call it that for now, but we're going to change it slightly later in the second part. But just for now, we're going to do this right here. So in add points, what we need to do is we need to know how far we are down the kind of list. So to know that, what we need to do is, if the event is already happening, we need to get the timer, and we need to know how much time has already passed. So we're going to get timer elapsed time. And with this, we know how much time has passed since the initial 8 seconds started. So we're then going to clamp this value, so clamp float, between what we're going to call 0.02 here, which is 60 frames, which we actually need to change in our class, or our class default, sorry. But we're going to change our tick interval to 0.02. So just that the tick happens every 0.02 seconds instead of based on the frame rate of the computer. So the max we want, though, is we need to put it to the scan duration. That way, no matter what happens, we'll max out at the maximum, and the minimum will be at least 1 frame. So this then all needs to get saved into an array. So we're going to promote this to a variable, which we're going to call, we'll call it instance array for now, because we're going to actually have to make a structure later, but for now we're going to do it the simplest way as possible. We want to right click to turn it into an array. We're going to get this, and we're going to say add, and we're going to add this value right here. Now, on the other hand, if this timer isn't currently running, then we just simply need to add the value of our max scan duration. And so both of these obviously return very quickly, and we then move on back to our scan area to timer complete. And so now we'll do timer complete. So what we need to know is we need to know whether our current last index or our current first index within here, within our instance array, if it is supposed to be finished. And so to know if it needs to be finished, we need to get a copy of our first index. And so what this will do is it will say, well, the first element that we added to our list, so the oldest element, how long has it been running? So to know that, we're going to put a minus here, and we're going to subtract the elapsed time from it. So the elapsed time is in our scan timer. So we're going to get timer elapsed, and we're going to plug that into here. Now, if this is ever inferior or equal to 0.021, we'll put, so if it's ever below 1 frame, or almost 1 frame, then we need to remove some elements. We need to remove the initial elements on that array. So to do that, we just want to do a for loop. And the for loop is going to be right here. So on true for loop, we'll get, so right here, we will say points per frame, and we're just going to remove them from our instance. So we're going to say remove instance. I don't know if instances will work. No, just remove instance is easier. And we're just going to loop through and remove the first instance, because either way we're removing the oldest one. So the oldest one will always be the instance 0. So we simply just loop through 7 times in our case, and simply remove that instance 7 times. So remove the newest one. Then what we need to do is we need to say, well, we just removed this element. So remove index 0, because that's the one we just checked. If it's done, we remove it. Now, on the other hand, if that is false, if that is not true, we need to update this value, the instance 0. So we're going to say set array element, so right here, and the element we're looking for is 0. That doesn't change. What we need to do is we will tell it to be this. So we can copy that and place it right here. Plug it into the item. So once again, we get the value that it initially was, we subtract how much time has passed, and we set that to the new value. Go, line them up again. And we can just add a reroute. We're going to relink these two up. All we need to do now is, dependent on this, if this is empty, so we'll do is not empty. If it's not empty, then we just want to continue with a new timer. Otherwise, we'll just cancel this one and say we are complete. So clear and then validate. So, and the reason we're doing this is because in our scan, we can call it directly, even though this is still running. So right here, we're going to say set timer. Actually, we'll just go to our scan area and copy this. And the only difference is, instead of scan duration here, we're going to use our instance array and say get a copy. And that will be our timer. And so normally with all this, we should have a means where we, if our most recent object is below 1 frame, it'll delete all the original, the first in the list that we created, and then it will move on and remove it from that array. And if we still have some items in the array, we'll get the newest length and restart the timer. So let's give this a try. If we just left click, we make some appear. And normally if we wait about 8 seconds, they should start to disappear. So it's crashed. Okay, so the reason it might have crashed for some of you is because in our remove instance here, we are sometimes, and I'm not exactly sure why, we are removing instances that don't exist. So it causes the program to crash. So to simply avoid that, we're going to add a branch that checks for the references just to see if it is enough, if there are enough of them. So we're going to say get instance count, and we're going to see if it is superior to 0. If it is, then we can still remove. If not, then we just stop. There's no point, we'll just ignore the rest. We could do it as a break, but just for now, we'll just do that, it's fine. Let's try it again. We'll add some points. And they should start disappearing about now from left to right. There we go. And they're all gone and everything's fine. So that does it for the whole making them appear, making them disappear. The next step is simply to make the world disappear. So to do that, we will go into our first person in our blueprints, and we're just going to use the game mode for this. So if this shows up like this, just open for blueprint editor, and then we're just going to be right here. We're going to look for begin play, And within our begin play, we're going to just do a few things. We're going to get all actors of class, and we're going to be looking for actor, just the basic actor, and we'll just do a for each loop. Now, you don't have to do this way. You could also do it in the player. There are many other ways to do this. We're just, for simplicity's sake, doing it this way. We're going to get components by class, and we're then just going to look for any static mesh component and tell it to, well, set itself as invisible. So we're going to say set visibility here to new visibility being null. And then what we're going to do is we need to make sure that now, so if we play this right here, what will happen is any static mesh will become invisible. So it's still here, we just can't see it. So next, what we need to do is we need to make the world dark. So to do that, we could delete every kind of thing we have here, but we can also make it so that it's non-destructive as a workflow, and so that when we edit levels, we can still see stuff. We're just going to make it so that we just delete those actors. So we're just going to say get actor of class, and we're going to look for the skylight here, and we're going to check if it is valid first, and if it's valid, we're going to destroy it like that, and just reroute here like this. There we go. And then we'll do the same thing, but not this time the skylight. We're going to use the directional lights, and we want to get rid of that the same way here. So just copy this over, plug in the input, and then destroy. And now, if we go ahead and play, we have a completely black world, but if we hold left click, we actually start to see the environment. And all the points obviously go further, and we can see from behind the points there as well. And they are starting to disappear over there. And if we wait a little bit, the rest will start to disappear too. And we can start doing it again normally. There we go. As long as we're not looking at the sky, it'll be fine. So there we go. So that covers making a very basic, bare bones, and pretty much functional LiDAR scanner in Unreal Engine. So I hope you enjoy it. In the next part, we'll be adding colors, modifying the shape, making it so that we can just do like a horizontal scan or a vertical scan, like a small line. And also we'll make it so that, for instance, if you scan a enemy or you scan a interactable item, it appears as a different color as well. So I'll see you for the next part. I hope you enjoyed. Goodbye.